Hello, fellow economists. Welcome back. Today I'm going to give you guys some of the tips for the new homework looking at different types of competition, firms in perfect competition, monopoly, and monopolistic competition. In class, people said they were worried about number 1, number 5, and number 4. So real quick, let's talk about that. For number 1, it's basically based off that graph. So I'm going to switch the camera and give you guys a look of what I would do with the problem. I'm going to use the graphing tools in Word to demonstrate the deadweight loss area and how to find the perfect competition outcome and the monopolistic competition outcome, or sorry, the monopoly outcome. Using those tools, you don't have to do that. You can draw it, you can describe it. Let me show you what I'm talking about. Okay, so here is assignment 9, and number 1 asks you to show how this monopoly firm that is producing beer for a local market, where they'll produce, what quantity, and what price they'll charge for consumers. And then it asks you to calculate the profits for the monopolist, remembering that profits are total revenue minus total cost, and then indicate the deadweight loss associated with the monopoly. And so let's go down to the graph, and you don't have to have, print this out and draw it. You can draw it or describe it or talk about it in on your scratch paper like you normally would if you want, but I'm going to show you on the graph so you get a good sense of it. So the first thing we need to do is figure out where the monopolist is going to produce. And that's going to be marginal revenue to marginal cost. That's the one thing that's the same in every case. They all produce, any profit maximizing firm produces where marginal revenue is equal to marginal cost. And that's right here where the marginal cost curve in orange crosses the marginal revenue curve in black. So I'm going to go ahead and draw a line that goes all the way up from that point. And I'm going to take it all the way up to the demand curve, because remember, a monopolist can charge as much as they want. The only thing that's going to constrain them is the prices that consumers are willing to pay. And willingness to pay for the marginal consumer is given by the demand curve. So already we know that the monopolist is going to produce 1.5 thousand cans of beer. And here we can see from the demand curve that they're going to charge the highest price they can, which is $2.50 per can of beer. The next thing you're going to want to do is check how much that total cost is going to be for that 1,500th can of beer, and that's going to be given by that total cost curve right there at $2. So, the price is $2.50 per can and the cost is $2 per can. That should give you the ability to calculate the profits. The next thing you need to do is figure out the deadweight loss. And the deadweight loss is going to be the difference between the monopolist productivity and the perfect competition productivity. And perfect competition would have us produce over here in that long run equilibrium where price is equal to marginal cost is equal to average total cost, and that would be at this demand curve point right there. So that would be where perfect competition would be. The deadweight loss associated with the difference between a monopolist and perfect competition is that area beneath the demand curve and above the marginal cost curve, between these 2 points, between the perfect competition outcome and the monopolist outcome. And so I'm going to go ahead and draw that shape for you guys just to give you a sense of what that would look like. So going from the price that the monopolist charges to the equilibrium for perfect competition down to the marginal revenue, marginal cost point for the monopolist, and then closing that triangle, and it's a little bit of a wishy-washy triangle, but it's still there. That's that deadweight loss area. Okay, does that make sense? Hopefully that helps. Let me know what you think. Question 4 asks you to use the graph to find how firms would behave. This is a perfect competition firm, perfectly competitive firm. And so we want to know what they would do in the long run and in the short run at a price of 40 cents and a price of 60 cents. And just remember for this one, you want to think about the shutdown rule and the exit rule. What is this firm going to do in the short run? They're going to worry about the shutdown rule, which means they're going to worry about their variable costs. In the long run, they're going to worry about their total costs, right? That's going to be the exit rule. And so that's what you want to think about. And then you use the marginal cost curve and the price to determine what they would produce. So hopefully that helps. The last question you all had questions on, this was the one everyone had a lot of questions on, is this problem. And this is a look at the price and quantity demanded at every given price, and then the fixed costs and variable costs. And it asks you to calculate the marginal cost and marginal revenue for a monopolist. So I'm going to go up on the board and do that one for you right now. Okay, so for this problem, we've got a couple of different pieces of information, right? We've got let me make sure I can see everything here. Yeah, all right. We have the price, the quantity demanded, fixed costs, and variable costs. And so we go from a price of $10 to a price of $4. That is very, very dead pen. Okay, so we go from $10, $9, 8, 7, 6, 5, 4, and then the quantity demanded at each of those prices is going to go up as the price goes down, quantity demanded goes up, law of demand, right? So we start out with 0, and then we go to 1, 2, 3, 4, 5, and then at 4, a price of $4, quantity demanded is 6 units. Fixed costs are $8 all the way down. And then variable costs are going to increase as we increase production, starting with $0 when we produce 0 units. And then it's going to be 5, 9, 11, 14, 19, 26. So the first thing we want to do is calculate the total revenue and the total cost, and then that's going to allow us to calculate the marginal revenue and the marginal cost. So let's do those two things. So total cost is going to be $8. 5 plus 8 is $13. 9 plus 8 is $17. 8 plus 11 is $19. 8 plus 14 is 18, 19, $22. 9 plus 8 is $27. And 8 plus 26 is going to be $34. Cool? So far, so good. Now we don't need this anymore, so I'm going to erase it to save space. But this will allow me to calculate marginal cost, which I need in order to find an equilibrium. A monopolist or a monopolistically competitive firm or a perfectly competitive firm, they're all going to produce at marginal revenue equal to marginal cost. So we have to calculate those two numbers. So marginal cost for that first unit produced is going to be going from $8 to $13. So that's going to be an additional $5. Going from 13 to 17, that's going to be an additional $4, right? Going from 17 to 19, that's an additional $2. Then going from 19 to 22 is an additional $3. 22 to 27, that's an additional $5. And then set 27 to 34, that's an additional $4, $5, $6, $7, right? So now we don't need that either. Now what we need is to calculate marginal revenue. So we need to get total revenue first. Remember, total revenue is just revenue, right? It's how much money we made, and how much money we make as a firm, no matter who we are, depends on the price we charge and how much we sell. So we make $0 when we sell 0 units. But that first, what does this company sell? Coffee mugs, is that right? It doesn't say. Let's say coffee mugs. Why not? The first one sells for $9, so that gives us a total revenue of $9 times 1, or $9. The next one is 2 selling at $18, so now total revenue is $16. 3 sell for $7, that gives us a total revenue of $21. Or we can sell 4 at $6, which gives us a total revenue of $24. We can sell 5 at $5 each, right? 5 times 5 is 25. Or we can sell 6 at $4 each, and that's going to be the same revenue. 4 times 6 is 24. And already we can see that same relationship we're used to with marginal revenue, where marginal revenue is going to tend to go down because we can see that total revenue kind of levels off at the end. So let's calculate marginal revenue. Remember, marginal revenue is just the change in revenue, the additional revenue of selling that additional unit. And with perfect competition, it's a straight line. Marginal revenue doesn't change. But because a monopolist sees that law of demand, right, our willingness and ability to buy more as prices go down, they're going to see a downward sloping marginal revenue curve. So when we go from producing 0 to 1, we're going to see marginal revenue go from 0 to 9. So our marginal revenue for the first unit is $9. From going 1 to 2, when we sell our second unit, marginal revenue goes from $9 to $16. So that's going to give us an additional $7 of revenue. Selling that third unit gives us an additional $16 to $21, $5 of revenue, right? $21 minus 16. Selling that fourth, whatever this is, gives us an extra $3 of revenue, then 1, then -1, right? Because selling that sixth coffee mug or whatever actually costs us some of our revenue. We actually see our revenue go down from $25 to $24. Because if we want to sell that sixth coffee mug or whatever, we have to lower the price to $4, and that's going to affect our revenue. Every time we lower the price, that affects our revenue. Quantity goes up, but price goes down. So now that we have all of this information, we can do part B, graph the demand curve, the marginal cost curve, and the marginal revenue curve. And those are the 3 curves we really care about. Average total cost curve, also important. It helps us determine whether we're enjoying profits or losses. We need the average total cost curve to calculate profit or losses, but this question isn't asking us that. So we're going to just go ahead and use price and quantity demanded for our demand curve, and marginal revenue and marginal cost for marginal revenue and marginal cost. So that's what we need to graph. Okay? Ready? All right, let me show you how it's done. So, we go from about, let's see, checking back there, about $10. So that's where I'll put my peak price, 10, 9, 8, 7, 6, 5, 4, 3, 2, that's too low. There we go. And then we go from selling 0 to 6. So that's what I'll put down here on this axis. Woo! All right. Now I'm going to start with graphing the demand curve. And remember, when I give you the price and the quantity demanded, that is the demand curve, right? Demand curve is just how much people are willing to pay for a given quantity, or how many consumers are going to buy a quantity of a good at a given price. So at a price of $10, quantity demanded is 0. At a price of $9, quantity demanded is 1. At $2, it's, or at $8, it's 2. At $3, it's 7. Sorry, at $7, it's 3. At $6, it's 4. At $5, it's 5. And at $4, it's 6. And so that's a pretty straight line demand curve, right? Just the relationship between price and quantity demanded. Next, we want to do that marginal revenue curve. And I personally like to do my marginal revenue curve in red. That's just my thing. I feel like it makes more sense when you're calculating and graphing these marginal revenue curves to put them in between the units, so on the margin. You know, I've told you it's not that important. It's still not that important, but I'm going to do it that way because I think it makes a little bit more sense. So for our marginal revenue curve, remember the first unit gives us a marginal revenue of $9, and then 7, then 5, then 3, then 1, then -1. So I'm going to graph it this way, where I'm going to say that first unit gives us that first $9. And then the second one gives us $7. The third one gives us the marginal revenue of $5 right here. And then $3 for the fourth one. And then $1. It's going to be right here. And then this one's -1. So that's our marginal revenue curve. Make sense? Kinda? Sorta seems familiar, hopefully. The next thing I'm going to do is graph the marginal cost curve. We can't solve this problem without the marginal cost curve, right? Because we know the monopolist is going to choose a quantity based on marginal revenue equal to marginal cost, and then pull that up and go to the demand curve for the price. So we can look at our table and see, based on the marginal revenue and marginal cost we've calculated, where that's going to be, but I'm going to graph it anyway just to show it. So we're going to have the marginal cost start at $5. And then that's not 5. That's why that didn't make sense. 5, 4, and then 2, and then 3. And then marginal cost goes from, when we go from 4 units to 5 units, it's going to go from $3 to $5. Back up to here. And then from 5 units to 6 units, it's going to go from 5 to 7. So it's going to kind of give us that U shape. A little bit wobbly. That's okay if your graph's a little wobbly. It's just a little wobbly, right? These numbers don't behave as cleanly as we might like. But we get our equilibrium. So now the next part asks us to find the level at output at which the monopolist would maximize profits. All profit maximizing firms produce at marginal cost equal to marginal revenue in every situation. So marginal cost equal to marginal revenue happens at that quantity of 3. And then we pull it up to the demand curve to see the price. And this is where, again, you can go back to the table. You can see marginal cost and marginal revenue are both $3 at a quantity of 4. Oops, drew that wrong. Oops. Maybe it's not so good to go in between the lines. Marginal cost is $3 at a quantity of 4. Marginal revenue is $3 at a quantity of 4. And at that quantity of 4, the price given by the demand curve is actually $6. So in this case, the monopolist is going to produce a quantity of 4 and charge a price of $6. Cool? Make sense? See how it all comes together? The last question, part D, asks what the perfectly competitive market would do in the long run equilibrium and where that firm would produce. So if this market was perfectly competitive and in long run equilibrium, we would expect them to produce where marginal cost is equal to demand. And so that would be here. And we can go back up to the table to make sure and say, okay, well, marginal cost is equal to the price given by the demand curve at $5. At a quantity of 5 and a price of $5, marginal cost is also equal to 5. So that's the perfect competition outcome. Okay? Hopefully that makes sense. Let me know what questions you have. Make sure you get that homework in, and I'll see y'all tomorrow or next time whenever you're watching this.